Welcome back to World Decoder. Today we explore the massive, invisible engines that drive our modern digital lives and technology. We often talk about the tiny chips inside our phones. But have you ever wondered what happens when you press send? Or when you ask ChatGPT a complex question? Or when millions of people simultaneously watch a live World Cup final match? What kind of colossal power handles that massive workload instantly? The answer does not lie within your personal laptop or device. It lies in the underground cities of data, where tens of thousands of monster GPUs roar day and night without rest. Let us decode the story of data centers, the true physical brains of the internet that keep our world connected. Imagine a room as large as several football fields combined, but instead of players, it is filled with towering metal cabinets. These cabinets are called racks. Inside each one, you will not find ordinary computers, but powerful industrial servers built for speed. They are equipped with the strongest GPUs on the planet, like the NVIDIA H100 or Blackwell, designed for extreme computational tasks. If the GPU in your home PC is an athlete helping you game, then here, thousands act as a super army. These thousands of units are linked by ultra-speed fiber optics to become a super entity, working as one single giant brain. They no longer calculate individual image pixels. Instead, they chew through billions of complex mathematical calculations every single passing second. Their sole purpose is to train artificial intelligence models to understand, process, and replicate the nuances of complex human language. But this immense power comes with a dangerous price. A physical enemy that threatens to destroy everything if not controlled instantly. When thousands of GPUs operate at full capacity, they emit a terrifying amount of heat, enough to cook the hardware alive. If not cooled immediately, these expensive components would literally melt themselves down into useless metal within just a few minutes. This brings us to the most fascinating part of data center engineering, the advanced thermal management and cooling infrastructure systems. First is air cooling. Giant banks of fans blow continuously, creating a deafening roar that sounds like a jet engine taking off. Engineers carefully design hot and cold aisles to ensure fresh air reaches the servers while waste heat is efficiently removed. But air is not always enough. Modern centers use liquid cooling, running coolant directly over copper plates attached to the chips. Some even use immersion cooling, where the entire server is submerged in a special non-conductive liquid that absorbs heat instantly. Microsoft has even tested dropping an entire data center to the ocean floor to utilize the naturally freezing water temperature. This innovative approach saves energy on cooling, but presents new challenges in maintenance and retrieval from the deep sea environment. Beyond heat, there is the hunger for power. The electricity consumption of these facilities is staggering and hard to comprehend. A single facility from Google or Amazon consumes enough electricity to light up an entire major city for a long time. Why do we need so much power? Because every digital action you take triggers a physical chain reaction of energy consumption. Every time you ask an AI a question, it requires the simultaneous power of hundreds of GPUs to think and answer. When you save a photo to the cloud, it does not float in the sky. It lives on a physical drive. It resides on a spinning disk or flash chip inside a dark, secure vault located in the Arctic or a desert. This physical reality has turned data centers into the new battleground for global dominance and strategic technological superiority among nations. Today, national strength is not just measured by weapons, but by the sheer number of GPUs operating in their centers. The nation with more robust data centers can process information faster, develop smarter AI, and predict economic trends more accurately. That is why technology giants are pouring hundreds of billions of dollars into building these silicon cities all over the world. It is a race to build the infrastructure of the future, laying the concrete and copper foundations for the next era. So the next time you browse the web smoothly, remember the hidden world that makes that simple action possible for you. Behind that gentle touch is the frantic operation of a GPU army inside a steel fortress somewhere far away. The internet is not air. It is a massive physical system, consuming energy, generating heat, and occupying real physical space. The invisible world we call the internet actually has weight, has temperature, and has hearts of silicon beating without stopping. These silicon hearts pump the lifeblood of information across our planet, connecting humanity in ways we are just beginning to understand. Security is paramount. These facilities are guarded like gold vaults, protecting the most valuable asset of the modern age, Data. Physical access is strictly controlled. Only a select few are ever allowed to step foot inside the Holy of Holies. Automation is increasing. Robots now patrol the aisles, identifying and replacing faulty components faster than any human engineer could manage. Fire is a disaster. Special systems use inert gas to suffocate flames instantly without damaging the sensitive electronics with water. Redundancy is key. If the main power grid fails, massive diesel generators kick in within seconds to keep the internet alive. Newer facilities are moving towards green energy, using massive battery farms to store solar and wind power for sustainable operations. Sustainability is the new goal. Tech giants are building their own renewable energy plants to offset their massive carbon footprint. Even the waste is managed. Old servers are stripped for precious metals, ensuring that the life cycle of silicon is circular. The transition to green data centers is not just for PR. It is essential for the survival of our planet's climate. These machines help us solve global problems. They model climate change, predict storms, and help scientists discover new life-saving medicines. In healthcare, they fold proteins and simulate drug interactions, saving years of lab work and accelerating cures for deadly diseases. On the roads, they process data from millions of autonomous vehicles, orchestrating traffic flow to prevent accidents and reduce congestion. They are the backbone of smart cities, where every light, sensor, and camera talks to a central brain to optimize efficiency. Even in agriculture, data centers process soil sensor data to help farmers grow more food with less water and fertilizer. In education, they render immersive virtual worlds, allowing students to travel back in history or explore the surface of Mars. In finance, milliseconds matter. Data centers located near stock exchanges execute trades faster than the blink of a human eye. But with great power comes great risk. These centers are constant targets for cyber attacks, requiring ever-evolving digital defense systems. Armies of cybersecurity experts work alongside AI to detect and neutralize threats before they can steal or corrupt valuable data. Looking ahead, the future is quantum. Quantum data centers will solve problems in seconds that would take current supercomputers thousands of years. They will replace binary bits with qubits, opening up a new dimension of computing power that we can barely imagine today. As we build the metaverse, the demand for computing power will skyrocket, requiring even larger and more efficient data fortresses. The relationship between humanity and these machines is symbiotic. We build them, and in return, they shape our reality and future. From room-sized calculators to global networks, we have come a long way. But this is still just the beginning of the journey. The next generation will grow up in a world where computing power is as ubiquitous and essential as electricity or water. These underwater cables and land-based centers bind us together, creating a global nervous system that never sleeps or shuts down. Soon, space-based data centers and satellite internet will extend this network to the most remote corners of our planet. Bridging the digital divide means bringing the power of these silicon cities to everyone, unlocking potential across the entire globe. Researchers are even exploring storing data in DNA, which could hold all the world's data in a teaspoon of biological material. This could revolutionize data centers forever, replacing miles of racks with compact biological vaults that last for thousands of years. But for now, we rely on silicon, copper, and electricity. These are the materials that weave the fabric of our digital age. As the lights go out for the humans, the machines keep working. The blinking lights are a testament to our collective knowledge. In the silence of these halls, there is a deafening amount of conversation happening between machines, shaping the world outside. We have built an external brain for humanity. It remembers everything, calculates everything, and connects everyone, regardless of distance. As the sun rises, the data center continues its vigil. It is the engine that will GK us into the next century. We must solve the energy and waste challenges to ensure this engine does not consume the very world it helps us understand. Innovation is the key. The brightest minds are working on making these facilities cleaner, faster, and more efficient than ever before. Ultimately, these machines serve us. They amplify our ability to communicate, to create, and to solve the hardest problems we face. It all starts with a spark of electricity and a piece of silicon, but it ends with the infinite potential of human imagination. So appreciate the physical weight of your digital life. It is supported by the strongest pillars of engineering humanity has ever built. We hope this journey has unveiled the invisible giants that live underground and underwater, powering your every click and scroll. If you enjoyed exploring the physical side of the internet, please hit the like button and share this video with friends. Check out our other videos to decode more mysteries of the technology that shapes our world and our future. Thank you for watching World Decoder. Remember, the digital world is physical. Like, share, and subscribe for more deep dives. Stay curious, and we will see you in the next episode. Goodbye, and take care.